I'm from Canonical. I've started some famous releases as Focal Fossa, and why is the Snap Store not responding? So problems start off like this mogwai on the left. And unless cared for, this mogwai can turn into a gremlin, like on the right. Initially, observed behaviours aren't so critical, a bit naughty or mischievous, nothing we can't really handle. However, left unchecked, our gremlin will multiply into something significantly more sinister. It's pretty scary, huh? What started out as an understood problem has now turned into a complex beast. Early in my SRE career, I was in awe of the way my colleagues caught gremlins with skill and precision. I wanted to learn this skill. And this talk is for the engineer I was 6 years ago, uncovering the names of things I didn't know, or things I should be doing, and how to find out more. Problems come in many shapes and sizes. The 2 a.m. alert from PagerDuty, or a ticket from a customer. I'm sure you've reported one yourself while working on a separate task. So how we respond is really important. And the way we respond is triage. Triage, in a nutshell, is extracting useful hints to get started, and it's structuring our notes so that useful data is at our fingertips and it remains useful for the future. So as an example, this talk started life as just a collection of one-liners and links to literature, which isn't very useful for public consumption. I triaged the interesting and relevant detail and left out the stuff that didn't make sense. So triage is the best time to prioritize and figure out the right amount of detail for the issue we're now faced with. So what do I mean by the right amount of detail? So a ticket, for example, is going to be charged with lots of emotion. It's coming from a human. There's going to be lots of details that aren't really relevant. And an alert from PagerDuty is going to be quite terse. It might miss some behaviours or some characteristics that are important. So the goal here is translating these reports into a clear depiction of what's wrong. And the recording format is important, and a strategic format helps to unburden your brain. All the data should be there in front of you. Because there's nothing worse than having to alt-tab through different documents or scan up and down a Word doc just to find the information that you need, because it's easy to miss things. So I use a slip book. It's the German word for it that I can never pronounce. It's Zettelkasten. It's basically just a markdown thing, and I find that's really good for easier problems. For harder ones, a really good one is the A3 problem document. That one's really cool because you can embed stuff like diagrams and checklists into the one document while still having that focus. It doesn't really matter which format you use. The idea is to remain concise and have all that information readily available. So, solving problems requires critical thinking. And critical thinking is what separates us engineers from the gremlins. And reasoning is how we think through these problems. Human reasoning generally follows 3 different patterns. Deductive, which is basically like an if statement. So if I'm seeing this observation, it must mean this. As an example, when a mogwai gets wet, it turns into a gremlin. Therefore, gremlins appear when a mogwai gets wet. Inductive, which is basically generalizing based on the observation. So for example, my SSH session hangs. This is usually due to a networking error, so I'm just going to reset the NIC. And abductive, which is theorizing and predicting. You're basically taking an educated guess. So an example would be gremlins have me trapped. They are allergic to sunlight and are easily distracted. So to escape, I could open the blinds, and failing that, I can distract them with food. In isolation, methods don't appear very useful. We don't want to make assumptions, think up near infinite impossibilities, or gloss over critical details. However, used in combination, they really help to filter out unnecessary information while still paying attention to details. And our personal experience at education drives all of this reasoning, so you shouldn't feel bad if at the start you're struggling with understanding. I promise that it'll come in time and practice. So let's talk about methodologies. Methodologies are formal patterns for critical thinking. They're basically like the guardrails for thought. And some popular ones are plan, do, check, act, or the scientific method. This is one that is the medical model, and I've derived it, or I've adapted it from the SRE handbook. I like it because it supports just the right amount of thinking. I'm pretty prone to overthinking things, so the less unnecessary mental cycles, the better for me. It's structured enough to keep you on track. Generally, it's really good for like when you're just doing a deductive plus inductive reasoning thinking. It's basically just like a series of 4 simple steps until you reach a conclusion. So in a nutshell, examine, which is basically I'm looking for clues and gathering data. Diagnosis is where I'm making an assessment, doing some root cause analysis using reasoning. And remedy, which is basically forecasting based on that analysis, how I'm going to fix it, and then testing it or applying it. And cure, which is basically the follow-on from that, committing the fix. So I might update documents, update deployment specs. It's basically like just this post-surgery care plan. So contrast that to something like the rigid medical scientific model, which is an observe, hypothesis prediction, test, root cause analysis. And in that, you basically have a conclusion which is unclear. It's just a transition from a series of steps until you arrive at a conclusion. And it's really good if you want to use an abductive sort of way of thinking. So, for example, why I wouldn't normally use a scientific method for something really simple like an access denied ticket, once I've seen the proxy logs. It just doesn't make sense to waste all that time on that. So to recap, tools are used for deep thinking or quick thinking. And there are many more types of thinking, and there are many more methodologies that you can use. Okay, so Act 2, let's talk about how I would generally respond to a gremlin. So the first few minutes for me are about examining the dimensions of the problem. I would typically want to use like some inductive reasoning. So the first thing would be to confirm, is it really broken? Are users actually affected? Because sometimes monitoring lies. And the simple solution here might be actually just to detune it or silence it altogether. So at that point, after that, if I know that there's an actual problem and people are affected, I'll try and gather some rough measurements. Looking at error types, trying to find some low-hanging fruit, some quick fixes to reduce the urgency and give myself more room to breathe. And I think your effectiveness in the first few minutes will grow over time as you gather more scars and experience. So try not to spend too much time measuring things. If it's critical, the priority should obviously be to restore service as quickly as possible. So if you're stuck for questions or like how to analyze a Grafana dashboard or build interesting and useful dashboards, I've got some links on the last slide to help you get started. Okay. So techniques are basically how we see the forest through the trees. If we think of methodologies as the tools, troubleshooting techniques are the implementation of the tool. So which one you select and use really depends on the problem at hand. So I've kind of derived these from Brett and Greg's performance analysis book and the CCNP troubleshooting book. And I've kind of mapped them into the method, the techniques that are there, and then the goal that I'm trying to achieve. So running through them quite quickly. So top down is basically a good first step for sizing up the problem, doing some testing, like how are the user actually interacting with the system, what are the errors that I'm seeing, error codes and messages and stuff like that, how long are things taking. And divide and conquer is probably the most useful and interesting one in my opinion. So the goal there is about reducing or filtering the amount of possibilities. So a really good book that I would recommend to anyone is one called Algorithms to Live By. It basically really describes from like a computer science point of view why computers work, why these sort of algorithms, why are they good for certain problems like filtering and caching, and applying them in sort of like human examples that you can understand. Tracing the path is basically figuring out where the problem is. So using tools like traceroute or curl's really cool write-out flag, which lets you see timing from each step in the request. And comparing the differences is basically wanting to know what's changed. So like you can use tools like Git, diff, and then monitoring tools like SREcon22 and SAR. They let you see, like, comparing against the baseline, how things are performing now. And the indicators, obviously, that you want to see there are basically history and context. So component swapping is all about short-circuiting, getting that quick win so that you can reduce the impact. So some really easy quick wins might be to add an extra server, add more RAM, add more CPU. Because usually it's pretty cheap, especially if you're in a cloud environment, depending, I guess, how much scale you're at. And bottom up for me is typically a last resort. It's when I'm trying to work from fundamental principles, and that's where tools like TCP dump and performance analysis tools really help me to understand what's going on, and using git blame to see in the code why does this exist, and then tracing it back. Okay, so let's go into a demo. Okay, is that readable? No. Okay, so I've got this website. Where is it? It's my Gremlins database. So let's try and see what's going on. We've got a problem that it's unreachable. So we've seen our first gremlin. So let's look at that error code, unreachable. So typically that means that there's going to be some sort of issue with me and my laptop getting access to the site. So let's look at a top-down approach. So we've already tried to access it. We know that there's a problem there. So the next step down in the chain would be to take a look at why. So let's have a look at my routing table. So how do I get to Gremlins DB? Okay, so I seem to be going through Docker, but I know from my experience that this lab is actually in an LXD environment. So let's get rid of Docker, because it's not really necessary for this part of the talk, and let's get started. Okay, so now get onto Gremlins DB. But as you can see, it's quite slow. So this is the report I've got. Gremlins DB is pretty slow. Start clicking around. It's not that great. And yeah, so we've definitely got a performance issue here. So let's take a look. So using a little bit of inductive reasoning, I tend to find that I get good hints and good indicators by jumping onto the front end first. So let's do that. Okay, so let's take a moment to just have a look at what I've done. Just at a really high level, the goal here is to filter out and just select only the indicators that are relevant. So I don't know if you've ever catted or catted a HA proxy log in production, but sometimes it can take about a few minutes for it to run through. And I generally, being in Australia and catting a HA proxy log that's based in the States or the UK, tend to just reset my session. So really filtering, just looking at those error codes, getting a count, getting a frequency table of how many there are is really good. And then here, I'm basically just I really want to see the last few, because I don't want to have I don't want to skew my data. Like if I was to do this analysis on the entire log, then I could have my data skewed because there could have been a problem yesterday, and it's only really interested in the most immediate amount of requests. And here I'm filtering out and building that frequency table. So and doing it again just to make sure that those counters are increasing, and they are. Okay, so let's just have a quick look at how HA proxy is performing. Okay, so we can see that the queues are quite saturated here. The current queue size is about 1,702, and it's quite near to the max. So let's just do a live capture of how things are performing. Yes. Okay, so we found, so as we saw in like the last table, one really good indicator is like looking for IP addresses, like it's looking for patterns basically. And in this pattern, I could see the application was performing poorly. I looked for a pattern of like IP addresses, so what are the users that are using the service. And I found an outlier, a bad actor here, number 135476866. So let's just do a quick fix here. We'll just rate limit them. And then let's make sure our rate limiting is working. So another interesting part that I would like to talk more about is sometimes like metrics, they're not easily observed or found, and you have to look in really hard to find places like the procfs file system. So like hash limit is like a really good one, because the only other way I found that you can look at it is by passing the IP table's verbose output, which isn't great. Okay, sorry, I'm gonna have to like skip the next demo. So yeah, reloading HA proxy, and then checking again to make sure it's okay. I do have 2 more demos, which I'm not gonna get through, so let's just. Yeah. Oh, I think it's better if I talk, and I'll do the demo at the end, maybe. But yeah, that's it. I think it's more important than I talk my. Yeah. All right, but yeah, as you can see, like we fixed it, and performance is now pretty good. MogWiDB is online. Okay, so. All right, so I talked about invisible gremlins. So what's really interesting about that is, sometimes our tools don't really. Oh, I didn't talk about invisible gremlins. All right, I'm just going to run through this. So sometimes our tools don't really tell us, like our monitoring tools don't really tell us any useful information. In the next demo, I'll show you why. But basically, there could be reasons like due to cascading effects from tasks waiting on resource time. So I use the Squid profiling guide as an example. So in there, they basically they say, well, what could be causing the performance problems of my Squid cache? And in its short, it's basically everything. It could be disk I/O, memory use, CPU use. So looking at, like, for instance, top and just seeing the CPU usage at 100% isn't really a useful metric. And so what I find in those cases is a single indicator isn't enough to support my analysis. I'm going to want to correlate things like saturation with utilization or errors to figure out if there's really a problem. And so obviously I don't have that much time to talk about the use method, but that is one. The use method, read Brendan Gregg's performance analysis book, and some other good ones, like the golden signal and red. And I've got links to those at the end. And so, okay, so here's some techniques, breaking it down a little bit for how to find some invisible gremlins. So some scenarios there. So an example test of doing like a top-down approach would be, just something really simple like timing cat a really slow file, and then just measuring how long it's going to be. Inversely, a bottom-up approach would be using perf stat and to measure the rate of faults and how virtual memory is thrashing. And if I had done my second demo, which I've only got 1 minute left, you would have seen me use perf top to answer the question, which is one that I got stuck with really early on in my career, which is I want to know if the application is dropping packets or if it's the infrastructure or network. And using perf top is just a really good way to kind of like divide that way out, because if I'm seeing the application that I'm really interested in as being in the top PIDs that are dropping packets, then I can kind of like not really, deprioritize looking at the infrastructure and start looking at the application and below. And then, if I had done my demo, you would have seen me be able to add an extra server as a quick way to fix that. Okay, so I find the most efficient use of your time is not to spend it. So if I had gone through my demo, as you can tell, so it's doing things like profiling, tracing, and writing elaborate demos take up a lot of time. So I find that once I've got a bit of context and a lay of the land in the first few minutes, I tend to like kind of then take a step back and review like is more complexity really required, or have I encapsulated enough information? Keep it simple. I tried to show at the first slide just simple pipes as a way to get some useful information. Inversely, I could have, and then I also showed awk. It's a really complicated way of doing it. And I found that writing an awk expression is a lot of like trial and error. Whereas pipes, I can kind of chop one end of the pipe off and be able to still understand what's going on. So I usually find that I'm more productive using pipes. So yeah, and obviously short circuiting is about reducing the urgency and giving yourself more time to breathe. And yeah, obviously you want to communicate any workarounds that you're doing. So that'll be in the wiki, or a really good place to put things is just in the message of the day of the service, so that when the next person logs in, they know that you've done this weird workaround and they're not perplexed as to what's going on. So yeah, in reflection, critical thinking underpins everything I've been talking about, and I really only just like scratch the surface of it. But I find that if you can put a name to a thing that you might not have known about already, just by knowing that it has a name, which for me was reasoning, and those methodologies and techniques, it really helped me to kind of like take a step back when I am spiraling and think, hang on, like what sort of reasoning am I using? What sort of thinking am I doing? Do I need to change that and use a different type? Methodologies are obviously the way we can go about doing that reasoning in the right direction, and techniques that could basically turbocharge that and allow us to do that effectively. So yeah, obviously be aware of like invisible gremlins. Sometimes observations can be confusing, and keep in mind that some tools lack granularity, and there will be times where using lower level tools like perf are useful, but make sure that you understand what you're doing when you're using them, and don't get carried away. And it's easy to think that we need a fortress to keep gremlins out, and more often than not, a moat will work. So complexity, I find, is usually met with resistance from people, and it's also fraught with red herrings. It's really easy to get like spiral and get hyper-focused on a problem that isn't real. So yeah, try to keep things simple and don't overcomplicate. And yeah, digest your experiences. Use like tools that will let you index your information for quick retrieval. So I talked about using the slipbook system, which I find is really good because it's all indexed and I can find anything that I did months ago or even years ago, like instantly. So yeah, think of it as like sort of your own personal post-mortem. And yeah, confidence obviously will come with time and experience. So don't be like upset or frustrated if you're jumping onto a system and you just can't figure it out, and other people in your team can. Guarantee you it'll come with practice. Yeah, and be kind to your colleagues, raise bugs and issues, and don't forget documentation. Thank you.